So what I'm going to talk about today is a couple things. One of them being kind of how things have evolved from an evolution perspective of SASE in general, and different ways of adopting the capabilities that are included in SASE, in particular the ones that Bitglass has created and kind of push forward from a evolution perspective and innovation wise as well. So if we start off with the evolution phase of SASE, there are a number of things that have happened over the course of the tenure of the Bitglass as an organization, and how things have changed just in the market in general. So one of some of the first things here was back when we came out of, or actually when we were still in stealth mode. At that point, when the company was founded, there were some really fundamental access control patents that were filed associated with a number of things. And you'll see a couple patents on here, but this one in particular was one that was associated, well, two actually, associated with the SAML relay component. And so I was mentioned a couple times, I think once or twice in the panel and in some sessions at the beginning, around the respective controls that you can put in place with and without agents, okay? And so the SAML relay capability is one that allows us to put in a protection mechanism into an application or in front of an application and proxy the movement of data on the fly without actually installing anything on the endpoint. Actually, almost all the presentations today that you saw were done in Google Drive. And here you see, for example, the actual web page being proxied through actual Bitglass here by means of tying in through the single sign-on integration with SAML. So one thing that actually also happened when we came out of stealth mode in 2014 is we realized that a core component of tying in these apps was this SAML relay, right? But not everyone at that point in time had capabilities and identity providers rolled out. Some were thinking about ADFS or Ping or Okta or whatever it might have been, but it wasn't necessarily in place always. And so one thing that kind of pushed us evolution-wise to supporting identity as a service capabilities was one thing like that. So you can bring your own identity provider if you want to tie into one or more identity providers from a kind of input and multi-output perspective. If you think about multiplexing identity, which sometimes happens especially in large organizations or universities and whatnot, but these things were critical and remain critical for providing protection in an agentless manner. So this is really focused on that agentless proxy, the thing I was showing a minute ago in the URL. This is actually a slide from back in the day, from 6 years ago, where we have this AJAX-VM technology, which is one of the fundamental things that is put in place with respect to protecting applications without installing software. And so on the fly, like I said a moment ago, you're able to input a protection plane, a protection platform essentially in the middle. And so this is kind of somewhat of a throwback here, but this is the old Bitglass logo from back then. What it's basically doing is being able to provide this almost virtualization type layer where security is put around the application. So even though right now you're viewing this Google slide and seeing this presentation, what's actually going on is the code that's running that there's a lot of it actually from Google in particular, but also from a lot of the big players that have complex types of JavaScript, is this term called an AJAX-VM. And so what that's doing is it's wrapping the application, that JavaScript and that HTML and whatnot, inside of this Bitglass layer that's running inside of a browser. And so what happens there is that we're able to intermediate requests that occur. So pulling down and loading a email for Outlook online, taking in someone moving a file from their endpoint up into the cloud or moving it back from the cloud to the endpoint. You can then inspect and control what's going on. And so you can see everything that's happening from a logging perspective, but then you can also control it. And it really ties into any one of these apps. And so you see some of the major ones at the time back in 2014 being Salesforce with things like Lightning, Google and Office 365. And I'll talk a little bit about how we've kind of adopted and made that something that you can use on any application as well. But tying that in and being able to enforce security without having to install a software or configuration on an endpoint is really critical from a security perspective, especially in worlds where BYOD is becoming more and more prevalent. 2015 here, a patent for cloud encryption. So you'll see kind of evolution-wise, this start moving towards things that aren't necessarily considered CASB This one is one that it is kind of a CASB function, but is unique in the fact that we have a patent on this. It's basically searchable and sortable encryption for structured data. And so here is an actual old pic back from 2015 of the Bitglass interface. It's come a long way since then. But essentially what's going on here is you're able to protect with encryption or tokenization information inside of a structured data application, be it Salesforce or something else, and bring your own key. So you can tie into Gemalto or Talos or whatever you might have from a BYOK perspective and encrypt that data, remain control over the data, and still be able to interact with the app. One of the key things that makes this a differentiated technology is that it still allows the native functions of the application to work, right? So even though the solution is sitting in front of, in this particular example, Salesforce, what's going on is the data looks to the end user the exact same. So they're able to interact with the app in the same way they were before, yet Bitglass is in the middle providing security and protection and actually encrypting content in this particular case. Also back in 2015, this ended up being something that is really unique and stands out and is highly differentiated against all the other SASE players in the market today. This elastic API scanning capability, or the Polyscale architecture in general, which I'll talk to in a little bit more depth a little bit later in the presentation. But so if we focus on API back here, what we're showing here is some actual back-end graphonographs here of real traffic that's going on in our production environment. One being associated with Office 365, Outlook, and OneDrive traffic, which has a higher volume of occurrences, although smaller file size, because it could be things like an email or a calendar event versus a file in OneDrive. And so you see trains of people from a time series perspective, maybe being asleep, coming into the office, a lunchtime period, and whatnot. So these are upload events or NQ DLP events where someone, not an upload, I guess, an alteration of the content that causes a rescan. Okay, and this is a DQ event. So what we have done here is we've been able to actually elastically scale up and scale down as needed, and to service those NQ events in a very fast period of time. And so the reason that that's really critical is because you want this line down here, this backlog, to be essentially zero, as close to zero all the time as possible, because then when a new thing changes, a new email sent, new files altered or uploaded or whatever it might be, then that gets checked and that gets analyzed, and then they look for things like sensitive content that shouldn't be shared externally and whatnot, and you can take an action on that. Similar example, but instead of Office 365, over here with Google Drive, so less number of files because people send a lot more emails than they do alter files a lot of the times. You see NQ and DQ events in the 1,000 range here, but this is hourly, and so you see the line here just fluctuating back and forth. What the key thing really here is, though, is that the fast turnaround time is what you really want. So over here on the right, on the left, what you see here is a scan performance of kind of user activity and a trailing or lagging type analysis that occurs where something's in queued and then it's dequeued, and there was some period of time where it was in that queue, right? What we've actually done, and we've made available to customers who want to use it, is offered API scan performance with dedicated nodes. So on the bottom here, if you know that you have a lot of activity and you want to make sure that you have the fastest turnaround time, we can actually give you a dedicated instance just for your applications to do the scanning. And so that's an option that provides a number of things, including things like historical scanning or rescanning on the fly and whatnot, so that the actual curve and the lag time in minutes here is as minimal as possible. So much more about the elasticity in a minute, but this was one of the key innovations and a key thing that we monitor on a regular basis with automation and whatnot to make sure that we're performing as desired. Machine learning driven shadow IT. Nat touched upon this earlier. He was calling out the 665,000 different applications we have. This is something we developed also back in 2015, 5 years ago. Again, a kind of boilerplate type CASB feature. Interestingly, though, when we first came out of stealth mode and we offered our services in 2014, what we had was essentially proxies. And so we had a mobile solution that provided mobile security as an MDM alternative. We had proxies for things like those common SaaS applications like the Boxes and the Salesforces and the Office 365s and the ServiceNows of the world and whatnot. But there are other applications, right? And so this shadow IT discovery, we didn't want to just go and throw humans at the problem, which is what you see from others. Instead, we tried to automate as much as possible from a scanning perspective to be able to say, okay, do we know what this application is? Is it in the database, yes or no, as we look at things like URLs or IP addresses that resolve to FQDNs and whatnot. And we'll say yes or no. And if we don't, then we put that particular item into a queue that goes and automatically characterizes the application. So it'll go, it will analyze it, it'll characterize it as, let's say, a CRM application versus a file sharing application versus some type of purchasing system or whatnot. And then breaks those down and scans them cohort-wise against their peers and gives them an automated trust score. Now, we've advanced this over the years to have a cloud score and whatnot and track attributes and things like that as well. But the application database continues to grow, which is kind of unique here. And we've been doing for a while that our customers have been benefiting from. 2016, interestingly enough, this user experience monitoring became important with this. This is looking at traffic and making sure that you're able to identify where the problems might be. So there could be problems between the endpoint and Bitglass from a network perspective. There could be problems between the Bitglass cloud and data planes and the actual applications themselves. And you want to be able to identify where that latency is being added, right? And so here we're looking at from Bitglass to the application. That's the back end of the connection from the data plane in the cloud to, in this case, Office 365, that there tends to be seconds of latency that are being imposed there. And some of these things correspond to, you trying to identify what's going on. And so from an experience and monitoring perspective, if someone calls and complains, you can go look at one of these health dashboards and say, okay, wait, this looks a little strange here. It doesn't look like it's a problem between the endpoint and the Bitglass, or it's something on the back end there, and go trace back what's going on, look at things like down detector and whatnot and figure that out. And so this is figuring out and helping with performance monitoring, experience monitoring, what's going on. 2017 was basically a capability that we added where we said, you know what, we shouldn't have to, and we don't want to write any application-specific configurations for the apps from a reverse proxy perspective, okay? We want to be able to support any application. And so one of the targets for doing so and supporting so with the AJAX-VM was to make sure that we could support the main applications people wanted to support. And so in that second slide, I think I showed Salesforce, Office 365, and Google, those being ones that are highly complex. They're large companies writing really complex JavaScript and running a lot of things on the endpoints from a code perspective. And so what we did is we took a step back and we said, you know what, let's make this generic. Okay, and so we took our rewriting engines that live both on the client side as well as in the cloud, and we said, now why don't we make a capability so customers can bring their own applications. So in this particular example, a custom app that might be running in AWS that's running on a custom domain, and you can protect that in the same way you would with something like an Office 365 or a Box. And so with this, it allowed a couple different things. One is you don't have to call us and say, hey, I don't see a default app in the catalog. I see you have Box here and I see you have Office 365. What about this obscure app that's being used in Brazil that we haven't even heard of, right? Or an application that you develop yourself and have deployed in your own data centers or in your IaaS infrastructure. You can then bolt on Bitglass here in the same ways you would with the SaaS app and provide the same protections. And so I'll get into this a little bit later in more detail, but it's because you want to, in essence, provide the same types of security measures you would regardless of what the app is, right? It's an app you use for business, and it's a managed application that you have licenses for or whatnot if you'd purchased it. So protect it in the same way. You don't want malware to be uploaded to it. You want it to be detected in a zero-day perspective, be it through CrowdStrike, Bitdefender, or Cylance. You want to make sure that data isn't being exfiltrated, for example, to unmanaged devices. And this is a way to control that regardless of what the app is. UEBA is something that's really critical. That's user and entity behavioral analytics. That's another one of those Gartner terms there that John was talking about. SASE being a self-addressed stamp envelope earlier, which is kind of funny. But here you're seeing a bunch of different types of controls where you can look at activities that are atypical and do something about them, right? So I might want to identify that, I think this was also used earlier, but that someone logged in and the device is unknown. Or they're coming from a location that they didn't come from before, or maybe they're logged in right now inside of California, and all of a sudden I see an access and a login from Japan. you know, that might be a hacker, right? So typically you want to do things like require step-up multi-factor authentication, and you want to monitor what's going on, do exact data matching against data that might exist from a PCI, PII, or PHI perspective inside the cloud, control it in some way and whatnot. So taking all these different types of things over the years, we've continued to add different types of capabilities to detect the sensitive data and protect it, or look for anomalous activity and take action upon it. And so UEBA was a key thing to the platform as well. This is one of those things that starts shifting more towards the SASE end of the spectrum, even though it hadn't been really announced until August of 2019 from a Gartner coining perspective. 2019, this was basically all the asks, I would say, or all the prospects that we were talking to and the existing customers kind of changed. What was coming to us as requests for, you know, how do I protect my SaaS apps? Tell me about your CASB solution. It started dropping these acronyms. They started saying, how can we protect our SaaS applications in general? How do we protect from the web accesses that are happening? How do we protect our users in general, right? And so cloud security tends to be kind of the thing that people are talking about now, and secure web gateway capabilities are one of those things, right? So protecting against the web, protecting against malicious type software or phishing links, or someone trying to circumvent a acceptable use policy. So something down here, maybe blocking gambling or blocking pornography or whatnot on a managed machine. So basically what we did is we rolled out a capability that's tied into something we call our SmartEdge agent. That's something that sits on a managed laptop, right? And say there's, even outside the office, you can still provide protection and acceptable use policy controls and things like threat feed controls and stuff like that, all on the fly. So now you get this combined Zero-Day Gateway plus CASB capabilities. And then speaking more towards custom applications, ZTNA, or Zero Trust Network Access, which was touched on quite a bit, not necessarily the acronym, but Zero Trust in general by almost all sessions, actually, which is pretty interesting. The key thing here is that basically what we have done is we've taken the same infrastructure as we built upon our platform, right? We continue building out the platform, and we're building it out globally, obviously, but functionality-wise, like I said a moment ago, when I was talking about the any app capabilities, this is basically the same types of things, the same types of security that you would apply, the DLP and the threat protection. And so when someone comes, I think there was a question from the audience actually, when they were asking about VPN replacement. A lot of times when the pandemic happened, all of a sudden people are working from home, and now there's huge stress on VPN concentrators. And so people are looking for things that are more surgical. ZTNA is one of those where you can say, instead of just giving me access directly to the network, what I'm going to do is I'm going to give you access to a particular application on that network. But a lot of times, since VPNs don't really offer this, people tend to overlook the need for or asking or deploying DLP and threat protection. Those are really critical, right? For the same requirements that you would have with an off-premise or a SaaS application. You want to do that with your applications you've deployed yourself. And so we basically took the same infrastructure that we already have for both forward and reverse proxy, be it from a managed device or an unmanaged device, and allow you to isolate your applications, make a private access to them so that they're only acceptable or accessible through Bitglass. And so this is basically shrouding and protecting still the applications on the network without a VPN. And so that's more of this kind of SASE move towards especially CASB, secure web gateway, and ZTNA type controls. So thematically, through the years, what we've basically done is we've been rooted in some of these kind of fundamental access control patents and other patents that we have, and innovating with different types of technology. Uptime is a really key thing as well. Like when you think about a SASE platform or just a vendor in general that's providing security from the cloud, regardless of it's ZTNA specific or CASB specific or whatever, the uptime is really critical. And what you should be asking your vendors about when you're evaluating or even have current vendors is, what is the uptime? And a lot of times that actually isn't a question that gets answered very easily. Someone might tell you, oh, there's an SLA. And you're like, well, the SLA just means you give me money back. It still means I have an outage, right? So that's not good. So instead, what we've done, actually since 2014 here, is we've outsourced this to an external monitoring system. So this is even a third party here that's monitoring what's going on with respect to Bitglass at any point in time. And so we monitor the back and forth between apps that are most popular, things like Google and Office 365 that you can see here, things like the portal and the IDP functionality as well. So if we click on something like Gmail over here, you can see the uptime in the last 24 hours. Here you can see the response times. Here you can see countries that and what their latencies are and things like that. But what you can actually see, this is also publicly accessible. There's no login or anything like that from a proof perspective. You can look at all the months where this has occurred. So if I go here and I look at the history over the course of time, and I expand this back to 50 entries, here you see round trip times between an endpoint through the Bitglass proxy and to Google for querying various pages and whatnot and loading it. And you see this going back all the way to 2014. And so historically, we have pages and pages of this for what we provided here. You see lots of 100% and 99.98, but the end result is basically that our uptime as monitored by an external party is 99.99%. So if you don't know what that is at the vendor you're using today or evaluating, you should definitely ask. Real-time enforcement is really critical as well for both data protection and threat protection. And so there, all the things I talked about a moment ago are really key, and they kind of come together, as well as some of this security for both public cloud for performance and scaling that I'll get into in 1 second. So overview-wise then, what exactly are we talking about when we're talking about SASE? Well, this is a depiction here of basically cloud security and network security coming together, which is in that fundamental note by Neil McDonald from 2019 from Gartner. So what's going on here is that you're basically combining capabilities like data protection, threat protection, identity visibility with different types of networking functions, like some of the same types of things like threat prevention and whatnot, but URL filtering and DNS and remote access to basically combine security and connectivity together and protect that in a platform that's delivered through the cloud. So that's what their note says if you go and read it and check it out. So what does this look like? There's a number of components here from the Bitglass platform perspective that are I talked about a little bit maybe throughout the years earlier evolution-wise, but starting out CASB type functions over here for managed app protection, ZTNA type functions for protecting internal apps, web and unmanaged app controls for things like the secure web gateway type functions, and them all coming together in the center for visibility and identity and control. And we don't really care, and it shouldn't really, I mean, it does matter, but you want something that can enable access from both managed devices and unmanaged devices. And maybe 5 years ago, where there were some experiences where people, even though they bought Salesforce and they knew it's a cloud app, they'd use IP block lists to require you to push your traffic through the corporate network because they were combining a whole bunch of things they had on-prem that were providing the same services we're providing here in the cloud. They're combining DLP, they're combining identity, they're combining secure gateway categorization of URLs, threat feeds, and things like that, acceptable use policy controls. But instead, what we're basically done is lifted that off the network into the cloud and provided it as a service. So you see things here like UEBA and IDP functions and whatnot. So the key thing though, from a protection perspective is things have to function always. I mean, even though there are SLAs and whatnot, you want the service to be up all the time, right? And so what we've done is we've rolled out a public cloud-based SASE fabric. The public cloud for us has been really, really instrumental. There are other vendors that try to rack and stack their own data centers and essentially compete against the Amazons, Microsofts, and Googles of the world, which are huge giants, right? And so from that perspective, when, for example, we need to service some new load for the users being distributed and not be coming from the office anymore, access-wise, our cloud just changes on the fly. And there's a number of different ways to do this. One of the things that's critical here also that's quite innovative is this SmartEdge endpoint agent. That's our secure gateway that I was talking about earlier. One of the key differences though there is that agent actually runs on the endpoint. So instead of just kind of copying the old guard, we'll call it, approach of backhaul, where I take and instead of installing something on my network or installing something on my PC and forwarding the traffic all up to the cloud, we basically said, let's reverse that. So we took the data plane that exists in the cloud already, we miniaturized it, and we put it onto the actual endpoint itself. So what the endpoint's doing is actual TLS inspection, termination and man in the middle, doing that inspection of the full URL. So there are some other solutions out there that will do on the endpoint type inspection, but they only do it based on server name indications, SNI, in certificates and whatnot, and they don't actually break apart the full URL there. And the problem with that is that hackers have taken notice, right? The other problem with that is that when you do this approach and you're not doing it on the endpoint, you're backhauling it somewhere, you introduce a lot of latency, which slows users down and causes problems. Backing that up though with the CDN is really critical there for things like lookups to categorize something. And then being as close to a actual end machine as possible is also critical. So that's where these local edge data centers come in. And then the core is more about things like reporting functions and analytics and UEBA and API scanning and stuff like that. But what we have seen is that in places that do not have the best connectivity, an example down below from Sao Paulo, is basically that when you get on the network and you come in through one of these local edge data centers, it's actually improving the connectivity times to something like Office 365. Not in all cases, but in some cases, which is nice because the fabric basically has established a better connection than the user could have between the endpoint and the SaaS app. So that's really critical. And again, of course, the uptime. But what if things change, right? So that elasticity that I was talking about with respect to the API earlier applies generally to the cloud. So this concept that we call polyscale or polymorphic scaling is also something we invented, much like AJAX-VM terminology-wise. But what it basically means is that as things change, we are able to dynamically on the fly scale up and scale down according to the needs. So and that's in the public cloud again. So again, if someone's usage pattern changes, or let's say we sign a new customer and there's all of a sudden 200,000 new users that come onto the network, you don't want that to affect your company's ability to access their applications, right? Or the capabilities that you already have deployed. And so what happens here is we scale up and down on the fly, and we don't do this manually. This is actually monitored in an automated fashion. And a key thing there also is this key technology down at the bottom that we didn't really realize, I would say, until maybe last year, when we started hearing it from some of the evaluations that were going on with the product, is that some of the other vendors are actually not multi-tenant. They deploy a tenant just specifically for that particular customer, and sometimes those are app specific too. So instead of that, what we're basically doing is maintaining an architecture that is stateless, multi-tenant, and multi-app. So if this new customer comes on and they happen to be using Box and trying to protect Box, both with API scanning, let's say, and the proxy, and then another Box customer comes on, that's not swamping the same singular set of Box nodes, because those don't exist in Bitglass. They're generic, they're multi-app, and it doesn't even matter. We scale up on the fly as needed. Same thing is true with respect to regardless of where the people go. So if people move around, this scales up and down on the fly as well. And this is quite unique and really allows us to quote unquote sleep at night, right? Because we don't have to be monitoring this all the time and things are changing on the fly as needed. It also has a cost benefit to the end customer, because we don't have to go and pay to rack and stack our data centers and make sure that there is enough capacity in them so that if a peak happens, we don't have an outage, right? Instead, we spin up more boxes because they're available inside the public cloud, and those machines or those VMs or containers are also on the fly being upgraded too, because we're getting the latest hardware as well from the public cloud, which you wouldn't get if you try to deploy this yourself. You'd have to go out there and do that, which is pretty difficult, especially in these times with COVID. The result is basically 300 different points of presence to deliver our service around the globe. So we have this local edge and CDN and core data centers all over the place around the world, so that the service for the end users is as best as possible. And we continue to expand this and roll this out. Like, for example, we have a Canadian specific cloud now that's offered. If you didn't want to do this, also, there are options to deploy Bitglass in your own data center if you wanted to, or even we even have actually customers that have purchased and deployed it in different types of regional specific data centers or their own AWS clouds, for example, as well. So let me get into a little bit of the benefits here, the performance. This is an example that is a real life example from one of the top 3 auto manufacturers in Europe. What it is a speed test that was performed with that on agent or on agent-based approach on the endpoint for doing secure web gateway type functions. And what they saw from an individual user type perspective that may have had 2 megabits per second, for example, connectivity wise, when they were measured connecting to the app direct, is something like a 5% drop when Bitglass was involved. But comparing these other vendors over here, these are two of the top leaders in the Gartner Magic Quadrant for Secure Web Gateway, and one of the other leaders of the CASB Magic Quadrant from an independent vendor perspective, dropping over 50%. And it was a huge benefit that just blew them away. And they said, oh, you know what, I can't even live with some of this. And you would expect some of these other vendors being, you know, the top 2 ones, especially from Secure Web Gateway, doing it for many years, to not have such an impact, especially in Central Europe. But this is basically a result of that innovation of taking something from the cloud, doing it a different way that has huge benefits to the end customer and the end user. And we're always doing this to try to remain as transparent as possible. I mean, this is hard to notice a 5% change over here, whereas you would definitely notice trying to do your daily job and have it be 50% slower, right? So that's really critical. Integrations are really critical as well. And so what we've done over the years, which is quite different, I would say, approach-wise than others as well, is we've tried to make things generic. And so instead of doing something specific for a particular identity provider like Ping or Okta, we said, SAML2 is a standard. Why don't we support the RFC for it and just be able to connect to any application, be it one that you deploy yourself, like a Shibboleth type use case, open source wise, to the big vendors that exist like ADFS or Ping or Okta or OneLogin or something like that. From a SIEM and UEBA perspective, basically we have a capability to take all your logs and ingest them into external tools. Like Amit and Lily talked about a second ago, there are Splunk apps that exist right now. There's actually QRadar apps too and others. But the idea down here with this infinity sign is, you know, you can tie it into anything. The key things though being also that as you move forward, you want to use things you already have invested in. So that falls under kind of some of the DLP type use cases. Sometimes you want to use ICAP to forward some of the capabilities and do EDR inside of maybe Vontu that you've already purchased and whatnot. So we support that as well. And then as Amit and Lily also mentioned, we have the integration with Phantom coming soon for that. And then also working on Demisto there. From a log ingestion perspective, there's just a list of a lot of vendors there. On the network side, typically that's for things like Shadow IT, but it doesn't have to be that either, right? As long as you have a timestamp and a source IP address and a destination IP, you could, and a URL optionally, you could do Shadow IT discovery and understand what's going on your network that you may not be aware of. There could be, you know, credit card purchases from particular groups that started using an app that you might not even know about. And all of a sudden, people are supposed to be using, let's say, Salesforce for CRM, and a fringe group started using Zoho themselves, right? So you can discover that. And you know, since it's so generic and it's something like a timestamp and a source IP and a dest IP, you could even get that from something like a DNS log. And so again, trying to be generic, trying to integrate with anything as possible, also with the big vendors, but then also just generically in any way you possibly can. So how would you go about implementing this? This kind of goes back to Evgeny earlier and what he was talking about with the strategy being something like a crawl, walk, run, and then assess and reassess. And so what we have going on here from a recommendation perspective for the crawl is things that are kind of out of band, things you can do immediately, right? If it's not going to impact the end user, then why not start forwarding logs up or scanning individual records that say, you know, what is the Shadow IT application? You can roll that out with things like syslog forwarding or manual upload or whatever you like to do that immediately, right, as soon as you evaluate or roll out the product. Same thing with APIs. So APIs connect, they don't affect the connectivity at all between the end user. You don't have to have the single sign-on, the SAML relay stuff deployed at all to do API scanning and take actions there, again, with that Polyscale capability. CSPM is something we didn't touch on in a ton of depth, but what that is cloud security posture management. We're also rolling out things like SSPM for SaaS security posture management. This is the same type of thing associated with looking at, you know, maybe I know that I have a CIS benchmark and I'm complying to that and I'm actively monitoring on a continual perspective with my Azure cloud, but is my configuration inside Box or ServiceNow is something that is also, you know, clean, right? Am I doing things in a way that can protect from accidental mistakes that can cause data leakage, right? When you get into more of the walk type time frame, we're talking about things like access control, denial of service protections. I think Nat talked about some of that earlier with respect to the panel and the opening statements around being able to say, hey, this looks atypical, or hey, this user is being attacked, and we need to do something about that. And so denial of service is really critical there as well. I talked about the secure web gateway components, that being that you can install it on the endpoint and see literally zero, almost zero degradation of performance, but still be enforcing acceptable use policies, looking for ATP and threats. And then one key thing also is augmenting the policies and changing them based on the device being known to be managed versus unmanaged. So if a device is an unmanaged device, and it is something that is that you're allowing to connect to your application, you probably want to put different controls in place. You're not quite sure how clean that device is. It could be infected with malware. It could be a personal device. It could also be a user logging in and trying to exfiltrate data. So they start to download data, and you want to control that in a different way. So this managed versus unmanaged device detection is really critical as well. SIEM integrations we kind of went through already. When you transition to the run type phase, there we're talking about some kind of more advanced type stuff. Exact data matching is one of those, as well as machine learned type signatures. So John was earlier talking about deploying and being able to use things like regex and keywords and things like that. Exact data matching is basically looking at structured data, let's say in a database of known customer information. Maybe it's a CRM or accounts that maybe exist. And looking at criteria like a first name and a last name. Now, you can't use regex for that, right? Because you can't put in, I mean, you could try, but a whole list of first names and last names. The efficacy of that is going to be pretty bad. So what people do is they create these tuples, essentially, of things like first name, last name, in a healthcare perspective, medical record number, social security number, the actual addresses of people, the phone numbers of people. And you have a row in the database that corresponds to that, but then you obfuscate that. We anonymize that and upload the anonymized data into the cloud, and we can match that at scale. So if you have 100 million records, maybe, you can match against that and say, okay, I now know that this is not just a fuzzy regex match of an SSN. It's a document that contains 50 PHI-related information about patients, and it's got someone's actual first name, it's got Mike, and it's got my address, and it's got my actual social security number. So reducing the efficacy of the false positives of regex type patterns is something that exact data match can help alleviate. Machine learning is also critical there too. So if I take a cohort, let's say, of sensitive information, and I put it in a folder, like all my POs that are finance related versus all of my forward-looking documents that I haven't published yet that might be roadmap related from a project management perspective, you can point the same type of thing, something that goes and analyzes those documents, pulls out and generates signatures, so you don't have to write the regex yourself. And so this automation and this more advanced matching is something we definitely recommend from a data leakage and a GRC perspective. Tendency and instance controls is something that's quite interesting as well. That's more about saying, I know that this right here is my personal Office 365, my Outlook account, versus the one that is corporate, and being able to differentiate between the two. Some people want to outright block and say, you can't use your personal address for the same type of app. Some people want to apply different DLPs and whatnot. So that's something that's interesting as well. ZTNA, I talked about, I guess, in a dedicated slide, so we can skip that. But making sure that you have the same posture there, doing the same types of advanced threat protection and DLP is really critical, instead of just access control like you would with a VPN. Threat feeds are interesting. There are a number of customers that pay for their own threat feeds, or curate and develop their own threat feeds, or trade threat feeds, or get them from open source places. You're able to actually take those and automate those and upload those into the platform, so you get that protection across the device for example, in that secure gateway type use case. And then I guess the last section talked about the SOAR playbooks. But one thing that's really critical about this whole thing is reassessment. And so what we actually like to do with our customers is meet with them on a regular basis. We actually have scorecards that we develop that say, hey, right now you're a 3.4 and you're right at the beginning of the deployment. So that's fine. But if you do these two or three things, additionally, it reduces your risk of data exfiltration. It reduces your risk of exposure. And here are the things to do. And we meet with the customers on a quarterly basis, or even every couple months, to assess them. And that's through the support organization, the customer success organization, and product management as well, to make sure that we get this happening. So we want to get you out of the crawl phase, into the walk phase, and into the run phase as fast as possible. But I would somewhat agree with that breakdown. I think earlier that was something like 60% crawl, maybe 30% walk, and 5 to 10% run. And the whole idea of reassessment is to accelerate that so that happens as soon as possible. So with that, I'll stop here. And I know I went a little bit over there, but ask for questions.
Thanks so much, Mike. There's several questions here. I think what we'll end up doing is I'll probably pick one or two of these, and then some of these we'll end up asking afterwards. I kind of like this last one or the first one, depending on perspective. When you're talking about ZTNA, the person is asking, and I guess perhaps they're surprised by ZTNA for BYOD. And so it's like, what does Bitglass do in the context of ZTNA for BYOD? Because
ZTNA for BYOD, that's a good question. Basically, it's the same type of thing that we did with respect to the reverse proxy, right? That agentless capability for when you log in and are able to sit in front of the app. So we can have a application behind your firewall protected, right? So it might be in my screenshot earlier. I guess it was. Let me go back to it and share it again. It was pictures of Confluence and Jira. Where did that go? So over here, basically, these are sitting on premise. You have a connector that reaches out to the cloud, and say I come from this unmanaged device, be it a desktop or a laptop or a tablet, like is in the picture. What basically happens is you're able to connect to the app by means of a portal. So you can go to the portal, the Bitglass portal, you can click on an icon, and it can take you into the app. So we've already done the authentication. We've already identified who the user is. Then we go and we do a policy analysis and say, okay, are you permitted to access this app or not? So maybe you are in the case of Confluence, and then we route the traffic through the reverse proxy. So you'd have basically this connection right here being a reverse proxy from the endpoint that's unmanaged to the Bitglass cloud, and then a connection that occurs over the course of this tunnel that's been established to the application in question. So the Confluence or whatnot that you have there. So you don't have to install any software or do anything, but if you did, and you installed something like an agent, then you can just connect directly because you already have that connection established.
And a final question to take us home for the day, Mike. What is the Bitglass licensing model? And I'll just assume that's more a matter of the structure of the licensing model per user, et cetera, et cetera.
I mean, one thing that's really critical that we've really paid attention to over the years is trying to maintain simplicity in the licensing model. So basically, we look at user counts and app counts. It depends on kind of what you're trying to protect. Sometimes when you're talking about CASB type use cases, that's more about each individual application. We don't have different prices per app. So you can buy things like bundles. Maybe I have a 5-app bundle of managed apps that I want to protect, but then I want to add on something like secure web gateway type controls. And then that's all based on a user count. So we try to keep it simple and not vary on the prices. There are other vendors that try to charge like hidden charges, almost like paying. There is actually one that requires you to pay for doing DLP on an application. So you think you bought Proxy and an API, but you didn't realize that now you have to pay an extra cost to even do DLP, which was one of your primary use cases. So keeping things simple is critical.
Cool. Wonderful. Thanks so much, Mike.